Good afternoon, everyone. I hope that you're having a great week so far and everybody's doing well. We're going to be looking today at lesson 30.19, which deals with sums and differences of functions. And this can be found on page 9 of your current lesson handout. So first of all, some notation that we have to be aware of. When you have the sum of two functions, the sum means you add things together. We write it in this form, and this is pronounced f plus g of x. And what f plus g of x means is f of x plus g of x. When you see a difference of two functions, it's written using this notation, which is pronounced f minus g of x. And what that means is f of x minus g of x. Now keep in mind these are functions we are adding or subtracting. And functions can be thought of either as graphs or equations. So we can be adding graphs or subtracting graphs, whatever that means, and we'll get to that. Or we can be adding equations and subtracting equations. So example 1 gives you two functions. F of x is 2x plus 1, g of x is x squared. And you're asked to determine the equation of h of x if h of x is f plus g of x. Well, all this means is f of x plus g of x. It's not complicated, and it's not meant to be complicated. It's just a different way to say we're going to add these two things together, which means that h of x will be equal to f of x, which is 2x plus 1, plus g of x, which is x squared, and we would probably write that as h of x equals x squared plus 2x plus 1, because when we write quadratic expressions, we usually put the quadratic term first. So this is h of x. Now we're asked to determine the following three things. F of 3. Well, f of 3, and this goes back to Math 10 and Math 20, f of 3 simply means we're going to take f of x, which in this case is 2x plus 1, and we're changing the x to a 3. So we're going to have 2 times 3 plus 1. And we can figure out what that is. We get f of 3 is equal to 7. And one interpretation of f of 3 equaling 7 is that when x is 3, y is 7. In the second part of this, we're asked to find g of 3. Well, again, in Math 10 and Math 20, you learn with function notation that when you're asked to find the value of the function at a particular number, it simply means you replace x in the function with that number. So what we end up with here is g of 3 is equal to 9. And another way that we could interpret that is to say when x is 3, y is 9. Now, how are we going to find h of 3? Well, h of x, up here we found h of x, is x squared plus 2x plus 1. That means that h of 3 will be equal to 3 squared plus 2 times 3 plus 1. So we can figure out what that is. H of 3, 3 squared is 9, plus 6 is 15, plus another one is 16. Okay, part C, determine the equation of the function k of x equals f minus g of x. Well, what does f minus g of x mean? It means take f of x and subtract g of x. So this time, to find h of x, we're going to take f of x, which is 2x plus 1, and subtract g of x, which is x squared, and we're going to get h of x equals negative x squared plus 2x plus 1. I just chose to write the quadratic term first. So now, what is f of negative 2? Well, again, f of x is 2x plus 1. So f of negative 2 will be equal to 2 times negative 2 plus 1. And we can work out what that is. Negative 2 times 2 is negative 4, plus 1 is negative 3. What is g of negative 2? Well, g of x is x squared, which means g of negative 2 is negative 2 squared. I haven't explicitly told you this in today's lesson, but I know I've mentioned it many times before. When you substitute a number in for a variable, put a set of brackets around it. So we get g of negative 2 equals 4, because negative 2 quantity squared gives you 4. How are we going to find k of negative 2? Well, k of x, we've discovered that's up here. K of x is equal to negative x squared plus 2x plus 1, which means that k of negative 2 is equal to negative times negative 2 squared plus 2 times negative 2 plus 1, and we can figure that out. Negative 2 squared is 4, but we are multiplying by a negative out in front, so we get negative 4, and then we have another negative 4, and then we have plus 1, which gives us a negative 7. The examples are illustrating something, and I hope that some of you picked up on this. If we take a look at the part B of this question, f of 3 is 7, g of 3 is 9, h of 3 is 16. If you were to take 7 and add it to 9, you will get 16. And we are adding the functions together. So what this is telling us is that in order for you to find the y-coordinate of a function that's a sum of two other functions, you add the two y-coordinates together. If we take a look now at D, well, if I take f of negative 2, which is negative 3, and I subtract g of negative 2, which is positive 4, negative 3 minus 4 gives you negative 7. So when we're adding or subtracting functions, it's really important that you understand we are adding or subtracting y-coordinates. If you are looking for the y-coordinate of the sum of two functions, it will always be found by adding the y-coordinates of the two functions. If you're looking for the y-coordinate of the difference of two functions, then you're going to subtract the two y-coordinates to get the new y-coordinate. It's always the y-coordinates that are being added or subtracted. All right, so example 2 gives you two graphs. One is f of x and one is g of x. And it says h of x is the sum of the two functions. So remember what that means is h of x equals f of x plus g of x. And it asks you to find h of negative 5. Well, h of negative 5 would be equal to f of negative 5 plus g of negative 5. So what does f of negative 5 mean? It means what is the y-coordinate on the graph of f when x is negative 5? We don't have an equation that we can put negative 5 into, but we do have a graph that we can put negative 5 into. And when I put negative 5 into the function f, what comes out is 2. So the y-coordinate is 2. Now we have h of negative 5 equals 2 plus, now we need to figure out what g of negative 5 is. Well, when 5 goes in, this is the point on g, and the point on g that comes out is 4. Before we go on, before you go on, you need to pause the video if necessary to understand how we're going from f of negative 5 to the number 2 and g of negative 5, how we're changing that to the number of 4. You have to figure that out. F of negative 5 is the y coordinate when x is negative 5 on F. G of negative 5 is the y coordinate when x is negative 5 on G. So now we can add these two numbers together and we get h of negative 5 equals 6. We're adding the y coordinates. Let me explain that in a different way for the second one. We want h of 0. Well, h of 0 on F is 1, and h of 0 on G is also 1. So we're going to be having 1 plus 1, which means h of 0 is equal to 2. We're simply looking at that x coordinate and adding the y coordinates. So if I take a look at h of 3, well, I go over here and I eyeball 3. This is my eyeball. And I'm going to add the y coordinates. Well, one of the y coordinates is 0. The y coordinate at that point is 0. And the other y coordinate is 4. Which means h of 3 is equal to 4. All right, well, what about h of 5? So I go over to x equals 5, which is right here, and I look at that, and I add the two y coordinates. I take the y coordinate on F and add the y coordinate on G. Well, there's a problem. The problem is F doesn't exist there. So think about this for a second. If I tell you to add the y coordinate that F has there to the y coordinate that G has there, you can't do it because F doesn't have a y coordinate, which means h of 5 does not exist. And that leads us to part B. What is the domain? The domain of the sum of these two functions will be x is less than or equal to 4, because as soon as you move to the right of 4, you don't have any y coordinates to add. I can add the y coordinates here. I can add the y coordinates here, or here, or here. I can add the y coordinates anywhere here. I can add the y coordinates there. But as soon as I move to the right of 4, I can't add the y coordinates. And the purpose of part B here is to illustrate to you a very, very important idea. And it's the same with differences as it is with sums of functions. The domain of the sum or a difference of functions is the domain that they both have in common. If you have one function that's defined from negative infinity to infinity, but your other function is only defined from 0 to 5, then you cannot add or subtract those functions except for when x is from 0 to 5. You have to be looking at where the functions are both defined. And in terms of domain, that means the domain that they have in common. You can also think of this as saying it's where the two graphs overlap horizontally. By the way, there is no range rule. You cannot look at two functions' graphs and decide what the range is going to be unless you actually graph the new function. Speaking of graphs, example 3 gives you two graphs. One function is f and one function is g. Notice that the domain of each of these functions is 1 to 5. They're both defined from 1 to 5. And that means that the domain of the sum or difference of the functions will also be from 1 to 5. All right, so A says, sketch the graph of f plus g. Don't forget that you are always adding the y coordinates. So if I were to take a look at the first place that both of these functions are defined, they are both defined at 1. Now, there is a point on f where x is 1, and there is a point on g where x is 1. When x is 1 on f, the y coordinate is 2. When x is 1 on g, the y coordinate is 0. So we add the two y coordinates. We take the y coordinate on f and add the y coordinate on g. That gives us 2, which means when x is 1, y is 2 on the sum of the functions. Now this gets a little messy, so I'm going to erase all of this. What about when x is 2? Well, when x is 2, we have this point with a y coordinate of 3. And when x is 2 on g, we have this point with a y coordinate of 1. So you add the y coordinates. 3 plus 1 is 4, which means when x is 2, y is 4. Now we move on to when x is 3. When x is 3, we have this point with a y coordinate of 4. When x is 3 on g, we have this point with a y coordinate of 2. So you add the y coordinates. 4 plus 2 is 6. So when x is 3, y is 6. And you continue to do this. What about when x is 4? Well, when x is 4, you're looking at a y coordinate of 4 on f, and you're looking at a y coordinate of 1 on g. So you add the y coordinates. 1 plus 4 is 5. So when x is 4, the sum of the functions is 5. We have one more to go. What about when x is 5? Well, when x is 5, the value of y on f is 4, and the value of y on g is that 0 again. So we add the y coordinates. 4 plus 0 is 4. So when x is 5, y is 4. And then we can connect the dots. These are going to be straight lines. I don't have a ruler with me that's handy that I could pull up, so I'm just doing it freehand. And that's the answer to the question. Now, be aware of something here. I could have asked you, instead of to sketch the graph, I could have said, what's the range? When you look at this graph, the range is going to be from 2 to 6. The lowest value of y is 2, the highest value of y is 6. But there's no way you'd be able to look at the two graphs on the right and say, oh, the range is going to be 2 to 6. It would be impossible. So there's no rule for range. For domain, well, we can look at both graphs and we can say that 1 is less than or equal to x, which is less than or equal to 5, because that's where they're both defined. You can't come up with a rule for y. Let's take a look at B. Sketch the graph of f minus g. The thing that you need to be careful of here is when you add things together, the order that you add them doesn't matter. 5 plus 8 is 13. 8 plus 5 is 13. But when you're subtracting, which you are here, the order matters. For example, 5 minus 8 is negative 3. 8 minus 5 is positive 3. The order makes a difference. So we have to be careful here that we remember we're taking the y coordinate minus the y coordinate, but it's the y coordinate of f minus the y coordinate of g. And we do the exact same thing. We look at the x coordinates and the corresponding y coordinates, and we're going to subtract. We're going to subtract the y coordinate at f, which is 2, minus the y coordinate at g, which is 0. 2 minus 0 is still 2. So when x is 1, y is 2. Moving on, what about when x is 2? Well, when x is 2, the y coordinate of f is 3. The y coordinate of g is 1. Remember, we have to take f minus g, so we take 3 minus 1, which is also 2. So when x is 2, y is 2 on the difference. Moving on, let's take a look at when x is 3. When x is 3, the y coordinate of f is 4. When x is 3, the y coordinate of g is 2. So we have to take the y coordinate of f minus the y coordinate of g. 4 minus 2 is 2. By the way, the reason we're getting a whole bunch of 2's here is that this line segment runs parallel to this line segment, so the difference vertically between them is always 2. That's going to change now as soon as we get to the next x-coordinate, which I think is going to be 4. When x is 4, the y-coordinate on f is 4. When x is 4, the y-coordinate on g is 1. We take f, which is 4, minus g, which is 1, and now the difference is 3. We have one left to do. We look at x being 5, and that gives you an output or a y on f of 4. When x is 5 here, the output is 0. So we have to take the y-coordinate of f minus the y-coordinate of g. 4 minus 0 is 4. So this is what f minus g looks like. And if you wanted to, you could write out the domain 1 to 5 and the range, which is 2 to 4. The only way that you're going to figure out the range, though, is going through this whole process of looking at the separate y-coordinates and subtracting them if it's a difference. That's it. It's not a long lesson, but it can be a little bit slippery to wrap your head around. First of all, you need to know that f plus g of x means f of x plus g of x. And that, I don't think that's a problem. And f minus g of x means f of x minus g of x. And that's probably not a problem. The thing that you really need to understand, though, is that it's the y-coordinates on the graphs that either get added or subtracted. One last note here, it doesn't have to be f and g. I can use any letter I want as labels for these functions. So on page 483 of your textbook, questions 1 to 4 and 7 are recommended for practice. Have a go at them. If you have any questions, you know how to get a hold of me. And that's it for the day. Have a great rest of the day, you guys, and we will talk to you soon. Take care.